Today's lesson is about the hypotenuse. The hypotenuse is the longest side of a right triangle. It has some interesting properties and is useful in both geometry and trigonometry. A right triangle has the required 3 sides and 3 interior angles. One of its interior angles is a right angle, which is always the angle opposite the hypotenuse. The other 2 sides or legs meet to form the right angle. In a right triangle, a leg can also be called a cathetus, plural, catheti. The 2 legs are, by definition, 2 altitudes or heights of the right triangle. The third altitude can be constructed by striking a perpendicular line segment from the hypotenuse to the right angle. In geometry, very few polygons get their own special terms. The word hypotenuse is reserved exclusively for the longest side of a right triangle. No other triangle can have a side labeled a hypotenuse. Pythagoras was a Greek mathematician and philosopher who is still remembered for the formula called the Pythagorean theorem, probably developed not by him but by the school of thought he created. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. If you have a right triangle with sides HYP, with leg HY measuring 5 meters and leg YP measuring 12 meters, how long is the hypotenuse? Let's plug the numbers we know into the Pythagorean theorem. This gives us 5 squared plus 12 squared equals c squared. This simplifies down to 25 plus 144 equals c squared. And we continue to do the math and we get 169 equals c squared. Now to find the value of c, we use the square root on both sides of the equation, turning it into the square root of 169 equals c. Finally, we get the answer c equals 13. That was neat and simple because we used a Pythagorean triple for our numbers. The measure of the hypotenuse may extend to several decimal places, requiring a calculator for the square root. Just as the word hypotenuse is reserved for the longest side of right triangles, trigonometry is a word reserved for the special branch of mathematics dealing exclusively with the relationships between sides and angles of triangles. The word itself comes from the Greek words meaning triangle measure. The mathematical relationships between sides and angles are called trigonometric functions. These functions are sine, cosine, and tangent. Their reciprocals are cosecant, secant, and cotangent. The Greek letter theta is used for the angle adjacent to the hypotenuse of the right triangle, and the leg opposite theta is referred to as the opposite. Here are the trigonometric functions that allow you to solve for lengths of sides. SOHCAHTOA is a mnemonic that can help you remember the 3 trigonometric functions relationships. SO for sine equals opposite over hypotenuse. CA for cosine equals adjacent over hypotenuse. TOA for tangent equals opposite over adjacent. Let's apply what we've learned in an example. Here is a very long, short right triangle with sides L, O, and W. Angle O equals 90 degrees and angle W equals 4.76 degrees. We know the distance of horizontal leg OW is 25 feet, but we do not know the height of the triangle, which is vertical leg LO. Remember, we know an angle and one side. The side is adjacent to our known angle. We want to know the length of the opposite side, so we use opposite over adjacent, TOA, or tangent. Tan theta equals opposite divided by adjacent. Tangent of angle W equals LO divided by OW. If we plug in our known numbers, we get tangent of 4.76 degrees equals LO divided by 25. Multiply both sides by 25 to isolate our unknown. So we have 25 times the tangent of 4.76 degrees equals LO. Now, you'll need a calculator to solve 25 times the tangent of 4.76 degrees. 25 times the tangent of 4.76 degrees equals 2.08 feet, approximately 25 inches. The height of leg LO, 25 inches, is not a random number. That is the proper height for a 25-foot handicap ramp using the recommended ramp angle of 4.76 degrees. Trigonometry has real-world applications all around you.